Welcome all of you to Ganit Samvad lecture series on mathematics. Topic is sets for class 11 Cbse. We are going to cover these points in this lecture: sets, roster and set builder form, subset of a set, and empty set. So let us start with definition of a set. A set is well-defined collection of objects. What does it mean by well-defined? Here, well-defined means if a collection is declared as a set, if we declare a collection as a set, then one can decide that a particular object, if we take a particular object, is element or member of that collection or not. If we can decide, then that collection can be declared as a set. For example, A is equal to 1, 2, 3, 4 is a set of natural numbers less than 5. Now, why this is set? This is a collection. Why this is a set? Because if I take an element, say 6, is 6 belongs to A or is 6 member of A? So we can see here 6 is not appearing. So 6 is not an element of this set. But if we take 2, then 2 is appearing over here. So we can say 2 belongs to this. So it means we can clearly identify the elements of this collection. So we can say this is a set. Similarly, if we take red, blue, black is a set of colors. So this is also a set. Now let us see this question. Which of the following are sets? Justify your answer. The first is the collection of all even integers. Now is it a set? Yes, because we know what will be the elements or member of this collection. What will be the elements? 0, 2, 4 and so on, and here -2, -4, all this will be member of this collection. So we can identify the elements or members and we can say which will be the element over here and which will be not. So this collection is a set. So the first one is a set. Now what about second one? The collection of 10 most talented writers of India. Now we don't have any criteria to declare that which writer is talented and which is not. So this may be a collection, but it is not a set. Again, let us see the third example, a team of 11 best cricket batsmen of world. Now again, we don't have any criteria that which the person is a best cricket batsman or not. So this may be a collection, but mathematically it is not a set. Now fourth one, the collection of all natural numbers less than 100. Now here we can clearly know the elements or member of this collection. What will be the members? Members will be 1, 2, 3 and so on up to 99. So all this will be a member of this collection. We can, if we write in a curly bracket and if we give any name, say A, so this collection will become a set. Because again we can identify if I write -3. So -3 does not belongs to this set. But if I take 3, so 3 belongs to this set. So we can identify the elements. So this will be a set. Now let us see. There are two forms to represent a set, roster form. Here what we do, we list all the elements inside a curly bracket like this way, 2, 4, 6, 8. Here A, E, I, O, U. And the second method is set builder form. Here what happens in set builder form, all elements of a set possesses a single common property. So we will have to identify which is the common property possessed by all elements of the set. And we use that common property to describe the element. For example, here if you see 2, 4, 6, 8, what are these? These are the even integers which lies between 0 and 10. All integers, even integer which lies between 0 and 10. So we can describe this by this way. How? That A contains all x where x is even and x lies between 0 and 10. So this set is in roster form, this is in set builder form. Like this way, The second set, A, E, I, O, U, this is all the vowels in English. So we can write this as a B set as all X, which where X is a vowel in English. This is the common property. Now any set can be represented by Venn diagram like this. Here you can see this is called the universal set, which we'll talk about later. What is it mean by universal set? And this set is A. Now note that in roster form, the order in which the elements are listed is not important. What is the meaning of this? If we take set A, this set as A, if in place of this, if I write A as A, if I take 6 first, then 8, then 2, then 4, then in this case it will be same set as this. So the order is not important over here. Okay. Now let us suppose that A is a set which contains all X, where what is X? X is student of class A whose height is greater than or equal to 5 feet. So what will be the members? The members will be all students of 11A whose height is greater than or equal to 5 feet. This is the criteria for this set. Now suppose Vijay is a student of class A and suppose his roll number is 5. He always comes first in every test. He is a regular student and comes to school in school van. Now tell, is Vijay an element of set A? How to decide? So answer is we cannot decide. Why we cannot decide? Because the information given 1, 2, 3, this is not relevant to the criteria which is given over here, that it is not told what is height of Vijay. So here we cannot decide whether it will be an element of set A or not. It may be or may not be. So this type of specific thinking, to the point thinking, is required in mathematics. So by this way, we have to think in mathematics. Now let us talk about subset. What is subset? A set A is called a subset of B. That is, we are talking about two sets A and B. And we say A is subset of B. We represent it by this way, denoted by A contained in B, if every element of A is also an element of B. That is, whatever is contained in A, that should be in B. For example, A is equal to 1, 2, B is equal to 1, 2, 3, 4. This implies A is contained in B. Why? Because 1, 2 is over here, all these elements appears over here. So A is contained in B. Now in Venn diagram, we can represent this very easily. This is the B set and inside this is an A set. So because all elements of A in B, so we have drawn the A inside B. This is the Venn diagram representation of subset. Now let us talk about empty set. What is empty set? A set with no element is called an empty set. Now it is a set, but it does not contain any element. For example, x belongs to n and x is less than 1. That is all natural number which is less than 1. But natural numbers start with 1, 2, 3, 4. So there is a no natural number which is less than 1. So this is an empty set. It represented by this way 5. Now triangle with 4 sides, there is a no triangle which is having 4 sides. So again this is an empty set. Next is even numbers that are also odd. So there is a no even number which is also an odd. So in this case again there is a no element. So this is 5, again an empty set. Okay. Now suppose you are asked a question about two sets. What is the question? Is set A subset of B? That is A contained in B? In this case, your answer should be we don't know. Why? A and B, if you are given A and B and told if A is contained in B or not. So answer should be we don't know. Why we don't know? Because we don't know about the elements of set in A and B. But in place of this, if you are given two sets like this way, A is this and B is this, and asked, is set A subset of B? That is A contained in B? Now what is your answer? How you will decide? So the criteria is, to answer this, we recall the definition of subset, which says, what is the criteria? set A is subset of B when if every element of A is an element of B. So what will be answer in this case? So clearly in this case answer is no. Why this is no? Because you can see 12 is appearing over here, but 12 does not belongs to set B, because 12 is an element of A, but it is not in B. So A is not a subset of B. So this will be your answer. But if question is asked, is B subset of A? That is B contained in A? In this case, the answer is yes, because you can see every element of B is contained in A. So B is subset of A. Okay. Now suppose we are given two sets A and B. In general, not particular, two sets are given, and suppose our task is to show A is contained in B mathematically. So how we will prove this? So how to do this? For this purpose, we take X belongs to A arbitrary. That is, X may be any element of A, arbitrary element. By somehow, if we can show that this element X belongs to B, then this implies that every element of A is in B. That is what we are doing. We will take an X belongs to A arbitrary. Somehow, if we can show that X belongs to B, it implies that every element of A is in B. So by definition of subset, A is contained in B. This method is required when we study higher mathematics. Now equality of two sets. Two sets A and B are equal if A is contained in B and B is contained in A both. For example, if we take A is equal to 2n and belongs to n and is less than equal to 3. So what will be the elements? N is equal to 1. So it will be 2. N is equal to 2. If we take then it is 4. N is equal to 3. Then it is 6. So this is the set. Now B set. All natural numbers which are less than 7 and which are even. So again we'll get 2, 4 and 6, which is written over here in curly bracket. So you can see this A is equal to B in this case. Now how to prove A is equal to B? To prove this, we have to prove that A is contained in B and B is contained in A. Okay. This Beamer presentation, can be downloaded from the link given in the description. If you have any suggestions, you can write in comment box. Also, if you like the video, then share with others. In next lecture of this series, we'll discuss about union, intersection, and other properties of set. Thank you very much.